Welcome, everybody. This is Sheila Heymans, the Executive Director of the European Marine Board. It is 1 o'clock Brussels time, and I am happy to welcome you all in our third Thursday science seminar. And in these webinars, we're actually showcasing the science behind our publications. So it's really great to see you guys here. And I'm really looking forward to hearing about the science we have today. So before we start, oopsie, I've gone too far. Before we start, just some housekeeping rules. Please, if you can rename yourself, that would be great, so we can actually know who you are. So you can rename yourself by clicking on your name there, on the participants and changing your name. If you have any questions, please use the question and answer for that, and make sure that you put your name and maybe which country you're from in the sort of question, and which speaker you would like to answer the question. If you have any technical issues, please use the chat function, and our technical support will help you. Please notice that this webinar is being recorded, and we will make it available on our website and on our YouTube channel. So if people were not able to be here today, then they can actually watch it later. In addition, one more housekeeping rule is that Nic Flemming, who's going to be speaking today, has some issues with his hearing, and he has basically got a speech-to-text converter, which will help to convert the text for us. But that means there might be a little bit of a delay with him answering questions. But please do make sure that you have you put your questions in the question and answer for us. So the focus of the webinar today is our position paper number 21 on the land beneath the waves. So it's basically about submerged landscapes and sea level change, sorry. So it's looking at prehistoric research on the EU continental shelves by crossing the boundaries between archaeology and marine geology. It is, for me, completely outside of my realm of experience, so I'm really looking forward to hearing from the two scientists that are going to be talking to us today. The document was published in October 2014, and it's based on the new research field on continental shelf prehistoric research that studies the remains of historic human settlements and that are now submerged beneath the seas. And it provides indications of how prehistoric people responded to changes in sea level rise and some of the prehistoric artifacts, and link those with paleoclimate models and sea level curves and sophisticated survey and excavation techniques. So really a very interdisciplinary position paper I'm really looking forward to hearing from about. So as I said, our first speaker is Nic Flemming. He's a visiting research fellow at the NOC in Southampton. He's a fellow of the Society of Antiquities, I think that's the right word, of London. He's a fellow of the Society of Underwater Technology, and he's the vice president of the Nautical Archaeological Society. So he's going to give our first presentation. And then second, we have Professor Francesco Chiocci, who is a marine geologist and a professor at the University of Rome in Italy. He's a chief of the marine geology section of the Italian Geological Society. He is a member of the Italian Oceanographic Commission and a member of the steering council of CONISMA, which is the consortium that brings scientists together in Italy, and is a member of the European Marine Board. So I think based on that, that's all I have. I'm going to stop sharing my screen now, and then I'm going to ask Jurka to please share the video from Nic Flemming.
We achieved a balance. We achieved a balance.
Having some problems, so give us a moment and we'll get the video to play from the beginning.
My name is Nic Flemming, and I chaired the working group that wrote the Subland report. The European Marine Board planned a strategic position paper on the submerged prehistoric archaeology of the European continental shelf during 2012 to 13, and the project was launched under the name of Subland in October 2013. We achieved a balance of academic disciplines to represent both the geosciences and the humanities by recruiting 6 marine geoscientists nominated by the European Marine Board and 6 prehistorians appointed by the European Archaeologia Consilium, which is the equivalent body representing all archaeological institutes and organizations in Europe. Thus, the sciences and the humanities were recognized at an equal academic and institutional status. The Subland report has 171 pages, quite a substantial book, and included over 60 recommendations. The purpose of this webinar is to assess the impact of the Subland report to see whether it had the effect that we wanted on the investment by government agencies and institutional support for continental shelf prehistory. Prehistoric sites on the seafloor are a very real occurrence. There are several thousand of them in European waters, and they range in age from 5,000 years to nearly 1 million years old on the seafloor. They've been surveyed by scientists and archaeologists in all European coastal states. Of these, several hundred are actual settlements where there were huts and people living for a prolonged period, and some of them are just artifacts and single anthropogenic signals such as a harp or a fish trap. The final books from the Splash Cost project were published in 2017, the book that I headed the editorial team on the landscape and ecosystems of the continental shelf, and then 2020 for the final book on the archaeological reports edited by a team headed by Jeff Bailey. The question now is, did the Subland report actually influence the way in which governments and agencies have invested their resources in submerged prehistoric archaeology in the last 6 years? There are several ways in which we could try to get a rigorous connection between the publication of the Subland report and the effect it may have had on government agencies, institutions and universities in terms of investment. Firstly, there's the citations in academic literature. I've got 36 citations to the report in my ResearchGate documentation, but there may be more, and we'll discuss that later. There's the impact assessment of the Marine Board itself, looking at European publications and documentation, and that gives an answer which is just about normal for their strategy documents. There's the evidence from the recommendations in the report itself. Of the 60 recommendations, I can deduce that 32 have been implemented, 15 have definitely not been implemented, and there's a middle ground of about 18 which have been half done and half not. There's the question of evidence from government changing policy. Germany definitely seems to have used the Subland report to influence its legislation, other countries possibly. There's the evidence of increased funding for continental shelf research itself in terms of prehistoric archaeology, but we don't know whether that's actually been produced by Subland or is growing for other reasons. There's the question of institutions and universities teaching the subject. From hearsay, it seems to be increasing. And then there's the influence outside Europe on other countries. In the following slides, we'll look at these items in more detail. trying to estimate the impact of subland from academic citations is obviously not strictly rigorous, because the citations are going to be by other academics, and they are 2 or 3 stages removed, as it were, from the agencies which actually make the decisions. The European Marine Board conducted a standard review and its own study using their usual techniques through references in the European administrative documents and so on, gave them a fairly ordinary or average impact for the position paper. There were 60 recommendations in Annex 4 of the subland document, and I've worked through these fairly carefully to see how they've been implemented. I gave the figures in the previous slide. The hit rate is really quite impressive. Some activities have been implemented by the UNESCO Marine Archaeological Unit, by EMODnet, and then there's been technical development in the 3D digital underwater photography, all sorts of improvements in acoustics, increased use of ROVs and AUVs, and collaboration with industry in using survey vessels. And all of these have helped to improve the yes score. But more input of ideas during this meeting would be valuable. It's difficult to prove a robust cause and effect link between the publication of Subland after 2014 and the continuing growth and success of submarine prehistoric research. The Splash Costs has continued to be active through the publication of its final books and its website, so that keeps interest going in the subject. Correspondence shows that Germany has been directly influenced by subland and has used it to revise some legislation. But input of ideas during the meeting would be valuable to try and get further information. But the situation has been very favorable. The year 2020 has been difficult because of COVID-19, and it's not obvious that funding has been continued effectively as it might otherwise have been, and people may have had to cancel their field research. But the situation has been very satisfactory for several years, and hearsay suggests that funding is still good. We hope that the inputs of subland would lead to an improvement in funding for Department of Archaeology, which would promote continental shelf prehistoric research, more teaching and perhaps qualifications, and even the award of PhDs specializing in this subject. Before 2005, the annual rate of publication was extremely low, and even globally there were only 5 or 10 papers per year addressing submarine prehistory. But Sturt et al. In 2018 did a really big search on the historical background of publications, showed that it rose to 50 to 90 articles a year during Splash Costs, and seems to have settled around about 30 to 50 a year now, up till 2016, which was the latest year for which we had data. The UNESCO Marine Department does keep a record of university courses, but it's difficult to derive from that whether the course includes a continental shelf prehistory or not. Subland could have had considerable influence outside Europe, if only because the reviews before publication, one of them was in Australia, but we know that the interest in submerged prehistoric research has been increasing quite rapidly in the Americas and South Africa and Australia. The subland draft was circulated quite widely before publication, and that may have influenced people in many other countries. In summary, subland and splash costs have been overlapping in their impacts for the last 5 or 6 years. Nevertheless, I think subland provided an extremely important foundation, which will provide a permanent base on which to assess the importance of investment in this field. Organizations, agencies, government departments are justifiably suspicious if something just looks like a fashion, an academic fashion, which can come and go. But I think that submarine prehistory has now really established itself as a completely permanent part of the mainstream of archaeology. And the Subland report shows that countries do have a legal obligation under the UNESCO Convention to support marine prehistory, and it's also important at the national level for protecting national heritage, and the issue itself needs constant negotiation with offshore industry. The academic research interest is not dying away, and more important issues are being discovered all the time about early prehistoric coastal settlements and early seafaring. Both programs, that's Splashkos and Subland, have therefore been very influential indeed. The following report, after mine, by Francesco Chiocci, will illustrate the success and growth of the subject with much more dramatic examples of fieldwork than I've given here.
Wonderful. So thank you very much.
Thank you very much for listening to my presentation. You will see here that I'm holding a mammoth tusk, which was trawled up by a fishing vessel from the North Sea.
Okay, thank you very much. I was a little bit too early there. So thank you very much, Nick, for that wonderful description of the impact of this report. And now I think Francesco is going to give us a really good understanding of what's in the report and what's happened since then. So take it away, Francesco. You can share your screen and go ahead.
Yes. So first of all, thank you very much for inviting me to give this speech. And also I'm very honored also to follow Nic Flemming, that is really the enthusiast engine of all this line of research. That I think it's important also behind what Nick said about or what the Marine Board did to measure the impact, because the main result was really to establish this new field that is really breaking the wall between archaeology and geology, so between science and humanities, if you want, and it is, I think, something that will be a long-lasting heritage of what has been done in the Splash Coast project first, and then in the work of the Subland working group of the European Marine Board, even behind the number of reference and the standard impact in the short term. So it's I will tell you something about these topics. I will try to be general, and of course, if you will have more specific question, you may ask after my speech. So this is just an example, or what has been dredged.
Francesco, I don't think we see your screen. Hey, so
oh, sorry.
I have to share the screen.
Yes, you're right. I'm sorry. Here we are. Okay, can you see?
Perfect.
Okay. So it's in this picture you have an image of what has been dredged in the North Sea. It is what before Nick was holding, and so in the seafloor you may find remains of prehistoric civilization that are very valuable, as I will try to explain to you. So first of all, for those that are not familiar with marine geology, we have to say what is the continental shelf, because we are talking about archaeological research on the continental shelf. So the shelf is this mass of land that nowadays is submerged by 100 meters of water. but that during the glacial period were emerged and and possible to use for the early population. In fact, during the Quaternary, that is the most recent geological era, we had that the astronomical forcing, the change in radiation from the sun, caused the ice masses to expand and to retreat several times. And so when you have the lower insulation, you have a very huge mass of ice, either in the North America and in Eurasia. And whilst this is the present day situation in which you have only Groenlandia and few other parts in North America covered by ice. The result of that is that this continental shelf, there is this shallow water, shallow in the sense of 100-meter water depth. So it's this red area represented here was in the last million years exposed and submerged several times. And nowadays, most of our activities, fishing, dredging for sand, and so on, occurs in the continental shelf. So it is used. It is the part of the ocean that is most used by humanity and will be more and more used in the future. All the cables, or all the industrial activities. And what is important for our case is if this is the sea level changes due to the fact that during the glaciation the ice masses trap a huge amount of water. So this amount of water is subtracted to the sea. So during the glaciation, the sea lower until to 100 meters. And you may see in the last 500,000 here, the rise and the fall of the sea level due to this climatic variation. So nowadays we are in this high stand situation, but as you can see, for most of the time during the Quaternary, the sea level was much lower than today. So what was going on this continental shelf nowadays is lying on the seafloor. Now we are not in a standard situation. We are in an exceptional situation because we are at the maximum of the sea level at the Quaternary scale. Not only this, but these huge ice masses load the crust, the air crust, and so lower the crust and cause subsidence because of the isostasy. So when they form, they let the crust subside, and when they melt, the crust tend to uplift. And the result of this is that, for example, if you go in the UK and you look today what the sea level is doing, you will see that in Scotland, in the northern part of the of the island, the sea level appear to fall, and it is because actually this part that was charged with the ice mass now is recovering, so is uplifting. So the sea level the relative sea level appear to go down. Instead, if you go to the south in England, you will see that the sea level is rising, and it is only the recovery of what was going on just beside the glacial masses that was an uplift, and so nowadays it is subsiding. So that creates a very complex situation of changing sea level, but also changing the water masses. And it is something that marine geologists and modelers know very well. And in fact, that creates, for example, here we see in the North Sea and the change of the coastline during the last glacial cycle, so from the last glaciation to present day, and this interplay between sea level that was changing and the seafloor that was moving as well create a very complex environment. For example, in the Baltic Sea, we had freshwater lakes in a certain period, and then they emerged, then the sea entered. So the situation is very complex, and in this complex situation, all the early human civilization developed at that time. So we call Paleolithic all the civilization that were going on during the Quaternary until the last cycle. So here you have again the sea level high and lowering and rising and lowering and so on for the last million years. And all this is the Paleolithic. In the upper Paleolithic, that is the last glacial cycle, we had the constant lowering from the 120,000 here down to 2,000 here, and then a very fast rising. The Mesolithic developed exactly in this time frame in which the sea level was rising. So this continental shelf were flooded. And then a Neolithic developed when the sea level was more or less at the position of today. So it's the Homo erectus, the Homo heidelbergensis, developed through the Paleolithic, and then we had the appearance of the Neanderthal that for a certain period overlapped with the Sapiens that in Europe we call Cro-Magnon. That was the early Homo sapiens in Europe. And so, for example, you see that the Neanderthal and the Cro-Magnon were living together for a certain period of time. But this period of time was a period of low sea level. So most of the activities went on the coast, because usually population occupy the coast, but in places that nowadays are flooded by water. And as an example, as an exercise, if we try to imagine what a future person may reconstruct of our civilization, if we rise the sea level of 100 meters, we may come up with this situation in which all the main towns that, of course, develop on the coast will be underwater. So this is not a realistic animation, but it's just to say that all this civilization that usually develop very close to the coast, because the coast is a place in which there is availability of food, of way to move, and so on. It's now are completely underwater. So what is this prehistoric research on continental shelf doing? Different aspect. One is the real looking for remains, and it is the first approach. So it's if you tell to a person on the street that we are doing archaeology on continental shelf, they will say, so you are looking for remains. We will see that this is not the main object, because the other object is objective is the reconstruction of the paleo landscape, either in terms of geography, how was the connection between land masses, either on the reconstruction of the environment, on the change of the environment that influenced the early human population. Let's first start about remains. So what survived on the seafloor? Nic already showed this map with these 2,500 sites that were collected mainly during the Splash Coast project. And as you see, they're mainly, no, here you cannot see, but they're mainly located very close to the coast. In fact, if we see the water depth of these sites that were in which remains were found, you see that they are in very shallow water. Those are meters of water. So the main cluster is in 1 meter or is in a few meters of water. And that can have two different explanations overlapping to each other. One is that the early population start to build something that may remain on the seafloor in the more recent time, so in the Mesolithic, late Mesolithic, and in the Neolithic. And the other one is that, of course, in few meters of water, you may have that the scuba divers may accidentally found something that is not the case if you go in deeper water. And in fact, what is the problem of finding archaeological remains on the seafloor is that the energy of the waves is very, very high, as you may see in these images of a rocky outcrops, I think, in England. And so the energy of the waves is very high. If you have a sea level that is rising, this sea level rising will destroy everything it will find. And of course, if we are talking about very light structure or very light traces that the early human population may have left, they have a very low possibility to survive the erosion of the sea when it's rising. In marine geology, we call that the ravinement process that is caused by the sea level rise. However, there are a few cases in which you may find remains on the seafloor. One is if you have something that is on land, so that maybe was in a marsh or in a lagoon, or it's on the pit, for example, and nowadays is eroded. So something that was on land, then was buried. Nowadays the coastal erosion is eroding, so it may expose what was once on land. And the other one is if you have a very fast sea level rise, but fast means that, for example, in volcanic or tectonic context, you have a strong subsidence that let the time of exposure to the waves very, very short. And an exercise that we did is to cross-cut the sea level curve with the topography of the seafloor, just to find what are the areas in which the transgression speed was higher, so the time of exposure to the waves was lower. And with this exercise that we did in Subland, we found that it's possible to identify areas in which the transgression was very, very fast, because they are flat and they were flooded in times in which the sea level was rising very fast. That is either in large scale and also in detail, for example, like in this area. So, for example, this is a way in which we may identify areas in which it's more likely that some remains may survive the erosion. Or, like in this case, you have that the wave erosion of today is exposing something that was once on land, like this site here. Or again, for example, this is Pablo Petri, that was discovered by Nic some decades ago, and then was studied by him and by other people. And this is a Neolithic that was at the beginning a Neolithic site that because of tectonics was brought underwater, and so survived wave erosion for a certain period. So those are some pictures of something that may be found on the seafloor, technique of scuba diver that are dredging materials. This is a very interesting, this is a footprint of a human in a pit layer that is exposed on the sea, a skull on the Baltic. That is very interesting. That is offshore the Israel coast. Those are some well that were digged during the Neolithic there. And those are, as Nic showed, the remains of mammals that were dredged, that are usually dredged by fishermen in the North Sea. That is one of the more that is very, very flat, and so that was flooded very, very fast. So this is for the remains, but again, the remains are common very close to the coast. There are very few in deep water, and this is one part of the story. The other part of the story is the paleolandscape. And paleolandscape, as we said, can be seen as the paleogeography. So, for example, to reconstruct the diffusion path of the humans. For example, here is for the population of the Americas that came from Asia. We have this Clovis corridor as an option, as the more accepted option. But maybe another alternative option can be the exposure of the continental shelf that again underwent a very complex story of isostatic rebound and flooding by the changing sea level that may have offered huge plain for the early population to move from Alaska to the continent. Or look what is the situation of the Aegean Sea during the low stand, and so, for example, the connection of Crete with the mainland Greece. Or this is an article that we published a few years ago. This is the Sicily Strait, so this is the Messina Strait, connection between Sicily and mainland Italy. And there is a time gap between the population of the sapiens in Italy and in Sicily. And the first appearance in Sicily is 1700, is 70,000 years ago, whilst in Italy is much older. And so using the present day topography, reconstructing the tectonic uplift, the amount of erosion, we were able to define with a certain degree with certain assumption what was the time of the connection between mainland Italy and Sicily. And it is not only true for the humans, but for example also for this Equus lontinus that is absolutely not able to swim, and also here the first appearance in Sicily is 20,000 years, so exactly at the time of the last glacial maximum. So this is one part of the story, the paleogeography. The other part is the paleoenvironment. So can the study of the continental shelf brings information of what was the environment, how the environment changed, how it influenced the behavior of the population. And so there is all the reconstruction of the environment. For example, here is in the North Sea, but we have a wonderful reconstruction also in the Baltic, in which we try to understand where the main water courses, the springs, the caves, and also what was the vegetation. All these are the main factors that are influencing how the people behave and where the people live. So this is a very important part of the story. For example, it is a reconstruction of the varied river valley. Here you see some details. So this is a seismic profiles that is, let's say, a sound cross-cut of the seafloor. And these black areas are areas in which the reflection is stronger, and you may use this strong reflector to reconstruct the path of the ancient river valleys or tidal inlet, to reconstruct where they were and how they evolved through time. And so this is the reconstruction that allowed, for example, in this area in offshore Netherlands to have an idea of what was the environment and how it changed through time. Or here we are in Malta, and here they were able to localize all the karst features, sinkholes, dolina-like structures, caves, and so on. And so this is another important part of the story for the paleo landscape. So this is more or less the core of what we have done in Subland, and then in Splash Coast, and then in Subland. And Nic already spoke about told us what was the impact in terms of project. Here I just summarized some projects that more or less deal with what we have done. I think that really many of these will not be possible without Subland and Splash Coast, just because the people that participate open their mind to new field of investigation, and so the proposal of project grow up from that. So it's not a direct feeding from the activity of Subland to the funding, but it's more a cultural opening of new field of expertise. So those are Horizon 2020 project, ERC project. This is a just launched INQUA project, Neptune, that is in paleo landscape reconstruction. There are also some national projects. One in Netherlands was just approved, another in Italy that I'm involved in that also was just approved. So it's I think it's there is a certain number of this paleo landscape that will not have been possible without Subland and Splash Coast. But the most important one is EMODnet. EMODnet is a very huge data infrastructure that Europe has set up to manage marine data. And EMODnet has different branches: chemistry, physics, biology, habitat, and so on, coastline, etc. And one is geology. And this is the evolution of this EMODnet through different phases. And exactly when the Subland publication was released, we had that among the different topics or the different aspects that were considered, we had the submerged landscape that was included. So nowadays, EMODnet Geology is working also in this collection of data on the seafloor for the reconstruction of the paleoenvironment. This is a very ambitious target because it's not easy. These data are not existing more or less. So it's not easy to produce something that at European scale can be accessed. But in perspective, it is a very nice evolution because it's just the evolution of the continental shelf through time that occurred, changing the sea level and the climate. So it's not only for the early humans, but it's also for geology, how the continental shelf evolved, at least in the last glacial cycle. So, for example, this came from the EMODnet portal. Those are the countries that contributed with the data to the database. Again, the database is in a very early stage, but it is almost impossible to have a full completed because the field is completely new. And for example, this is the Baltic. All these are the paleo valleys, the beaches that developed through time, the archaeological findings, and so on. And I will finish with this experience of the Rotterdam Harbor, because to me it is very important and is something that should be really exported to the manager to the land manager and to the people in charge of the operation. In this case, it was a very good case of collaboration, because during the dredging of the harbor, they put some extra operation that was essentially to sieve the material that they were dredging from the seafloor, in order to have archaeologists looking at that and looking for some finding from flints or other artifacts that can be used. So in a huge operation with a lot amount of money involved, as the dredging of the Rotterdam Harbor, that is a gigantic harbor, that was a very small part, and but brought some very interesting results. So to me, one point that should be very emphasize is the need that all this scientific information are transferred to people that are in charge of managing the coastline and the operation at sea. Because with a very little effort, you may obtain a good result. For example, also another point is when you have this large project of beach nourishment, weeks or months after you nourish a beach, the wave will rework the sand, and in the shore phase, they will expose all the remains that sometimes are shells, but sometimes can be flints. So why not just to have some archaeologists just going along the beach, looking at what nature is exposing for them. So that was all, and I thank you very much. And one thing is that in 2023 here in Rome, we will host the International Congress of the Quaternary Association, and of course the paleo landscape will be one of the topic that will be dealt, and of course you are all invited once this virus will not be longer in place. Okay, thank you very much.
Thank you very much, Francesco. That was awesome. I have to say it was a really good sort of idiot's-proof description, so even I could follow it. Thank you. So as I said in the questions and answers, please put your questions in the questions and answers. I've had two that came into the chat, and I'll ask them for now, but if you have any other questions, please use question and answer. So the first one is from Jan Says, and he asks to both Nic and to Francesco, what kind of new discoveries, for instance, in the submerged North Sea, do you expect in the years to come? Do you think that, could you foresee that there would be interesting discoveries? And I think Nic is going to respond to that.
Okay, shall I answer for the North Sea? Okay. There's a lot of work going on, and it goes back several glaciations. there's been extension from the area where the footprints were found that Francesco showed the picture. There are fossils on the beach, and divers have been working offshore from that place, going out to about 5 or 10 meters. They've found substantial Pleistocene faunal remains, woolly rhinoceros, mammoth bones, and so on, and work flints offshore, almost 1 million years old. So if you start from 1 million and come forwards, as Francesco's map shows, the North Sea was exposed several times. There's a dredging site known as the A240 concession, which was cored by a research project from the Wessex Archaeology, and they found tools and work flints going back 360,000 years, several meters below the surface. So the potential in the North Sea is absolutely enormous. As Francesco showed, the gradients are very low. You've got a gentle undulating terrain so that there are sheltered areas between the high ground. And as the water flooded over, there'd be many occasions when the waves would not be at all strong because there's land masses and low gradient protecting it. So we can anticipate archaeological material literally of every period of low sea level from now back 1 million years in the North Sea. Some of this will be triggered by finds in trawl nets, some by industrial projects like the Rotterdam project and so on. But the potential offshore in the North Sea is absolutely enormous. And I love the phrase that Francesco used. It's a cultural opening up. Subland was not, the way I presented it was rather bureaucratic, and I do apologize, but I wanted to leave all the fun for Francesco with all the, the real facts and discovery. But it's a mixture between this very serious work behind the scenes, logistics, funding, politics, and so on, and the excitement of discovery offshore. And it is a cultural change in the world of archaeology.
Yes, if I may add something about the North Sea, about the North Sea, but in general, is that as in many fields of marine sciences, the technology will open new field. So it's we are newer and newer instruments that allow us to detect small changes on the seafloor, small geophysical characters, or to explore cavities. So something that is not possible today. So as the technology will advance, of course, we will have new findings. However, it is still it is important to say that we are not only looking for findings, because there were very little findings. And as Nic said, you need not only a low gradient, but also sheltered areas, maybe also a nice substrate to preserve these findings that are very small. But the reconstruction of the environment is very important, and in a certain sense, that is also behind the archaeology. It's just the evolution of the continental shelf through time, and this is a very ambitious project, because you will see at the small scale how the environment became what it is today, and you may learn from the past what was the behavior of the, for example, coastline moving or the water resource and so on. So that is also, it's a way also to enter into the detail, the very fine details of the geological process that are forced by climate change. So if you want, in this sense, it is also very interesting also behind the archaeology and marine geology.
Thank you very much, Francesco. Then there is a question by my colleague Angel. He's basically saying, what threatens our underwater heritage the most? Is it human activities or climate change impact? So is it increased erosion due to stronger storms or ocean acidification, or is it really you know, fishing or any other human impacts. And I don't know if either one of you want to take it, Nic or Francesco. Oh,
it's a mixture of everything. Wave action and currents are eroding the sediments. Trawlers are dragging bottom nets and bringing up bones, and industry is digging things up. But it's a very strange mixture of benefits and costs. If there was no no digging up, no trawling, no mining or dredging for gravel, a large number of sites would not be discovered. So we have to take the good and the bad effects together. The Boldner Cliff site in the Solent Channel on the north side of the Isle of Wight was revealed by current erosion and incidentally by a lobster which was throwing flints out from its burrow. But the erosion each year is A, destroying the site, and B, revealing it more and more in a way which one could not excavate. So we just have to try and take the good things with the bad. Where things, you can't stop coastal erosion, you can't stop the seafloor from being winnowed out by currents and waves. We just have to respond quickly when things are exposed, when something appears on the surface, follow up clues very, very quickly. And as Francesco said, use all the technology we've got in rapid surveying, rapid assessment of the site, and where relevant, actually studying the site in detail and excavation. One of the big challenges of this work is the enormous range of scales. As Francesco was saying, you've got a scale of 10 to 100 kilometers or more in understanding the whole continental shelf of the dynamics of the environment, and then down smaller and smaller and smaller scales, trying to get more detail to sediment movement and the exact points where artifacts are preserved on the sea floor.
Yes, and one thing is also to be considered is that again, in the perspective, many activities will be moved to the sea. So we expect the continental shelf will be the site where we will produce energy, we will produce food, we will use for communication. So more and more there will be work at sea. So the human activities will interact with the seafloor. So it is important that, of course, here probably we are all scientists. So but the main effort should be in implementing a regulation, so that when you do work at sea, as Nic said, you use this work also to reconstruct. It's not okay. There is a nice story. When many years ago I was doing a research looking for relic sand to be used for beach nourishment in Latium, and in a conference I say, okay, this is the beach of the Neanderthal. And 1 week later, they stopped the work because the archaeological department say, oh, you cannot destroy a site like this. But that was just to say that was a beach of Neanderthal. And as I show, it is completely reworked, so you will not find anything. So it's important that we have regulation that taking the good will offer the opportunity to study this environment, because the remains are very, very rare and sparse. So it is difficult to find a single site well preserved. But there are many information that will came from industry, and industry will have more and more activities at sea in the near future.
Nic, you want to add? Yes.
I could just add a point to what Francesco was saying about regulation. It is creating the right legal and ethical environment that will get the greatest success. We can't stop the world. We can't just say no dredging, no pipelines, no oil drilling, no beach reconstruction, and so on. But if the regulations are right, and if we work closely with industry, and they usually find it very interesting, there's been a lot of good collaboration there, and we can get, I won't say the best of both worlds, but certainly the least worst.
Thank you very much, Nic. Now we have a question from Gemma Ercilla, I don't know, the pronunciation is never very good with me. And the question is to Francesco. It is, what would be the challenges or approaches for discovering new locations of archaeological sites in areas that still remain unknown?
Again, it is very difficult to answer. You can do something with the modeling probably. So just to find what are the location in which is most likely that something can have been preserved by the reworking of the wave, by the ravinement of the waves. And so this is the contribute that marine geology may bring, just to identify what is the likelihood is higher to find something, and then new technology will allow you to investigate them.
Thank you very much. Nick, yes, go.
If I could add a point there, detection of sites is extremely difficult. It's not like a Roman or Greek ruin underwater with ashlar blocks a meter across. We're looking for flints and even debitage that size. And at the moment, there's no remote study technique, remote sensing, which will pick that up accurately. And the human eye is the best indicator after a site has been detected by some other means, by coring or sampling. But there is a lot of work going on the chemistry of sites, the geochemistry of sediments, picking up the DNA in the soil, and very special scanning acoustic techniques, which may pick up a site over several meters. But the good point is that these remains are not like, say, a Roman mosaic, where if you put a dredger through it, you've smashed it completely. If a corer goes through a prehistoric site, you bring up a few flints, if you're lucky, the rest are still intact. And using regulations, as Francesco said, you stop excavation on that spot commercially and then go into research mode.
Thank you very much, Nick. Okay, so we have one last question, and I think we're running out of time, but I'm going to take the question anyway. It's from Vincent Gaffney, and he asks, the lack of marine settlement evidence is clear despite all recent work, even in the North Sea. Other than gross dredging operations, what should we be doing to remedy this situation?
I think that somehow Nick already answered this question, because the problem is that this settlement has been destroyed by the wave, unless they were buried under the mud or under a pit, and then that preserved them. But again, it's we are looking for something that is so small that our technology nowadays do not, for seismic, for example, do not allow us to have such a resolution. So it's again, the best way is to use industrial data to set up regulation, to use industrial data to have information on the seafloor. And as this, as I said, as the marine infrastructure will be growing in the next years, maybe that can bring a new information, and so that give rise to new research.
Yes, I think that just about covers all the details. The question of scale is so important, and I think Francesco and I have brought this point out. The prehistoric people migrated over considerable areas, they hunted over wide areas, they had scattered sites, caves, open air sites, and so on. And the movement of sediments, the mechanism by which the rising sea level came over sites, the redistribution of sediments and so on, all come into the picture. And I'm not sure it's a question of remedying a problem. We just have to live with the way things are going and exploit the good points when we can. If there's a beach excavation or recovery going on, put archaeologists on the site. If people are laying a pipeline, there are European regulations which are quite strict, saying that industrial projects have to make an assessment of the environmental impact, including prehistoric site impact. And this has been very beneficial. A number of sites in the North Sea have been revealed because of those European regulations. And the British Department of Trade and Industry, as was, picked up the regulations and have enforced them very strictly in Britain.
Thank you very much, Nick. Well, I think that is all the time we have. So I can only end by saying thank you so very much to both of our speakers. It's been an amazing hour. I've learned a lot. And I would like to invite you all to come back next month on the 19th of November, when we will have our next third Thursday seminar. And this will be on our document on advancing citizen science of coastal and ocean research, specifically with case studies in Norway. And this will be presented by Professor Carlos Garcia Soto and Dr. Gro van den Meren, which will be giving us our the presentations for next month. So thank you again to Nick and Francesco, and I look forward to seeing you all next month.
Thank you very much.